Welcome to Let's Talk Agri-Tech, podcast from the UK Agri-Tech Centre. I'm Sophia Hersher, and today we're going to be talking about the innovative and exciting GreenShed Project. So today we're going to hear all about this groundbreaking project, which is based up at Scotland's Rural College, SRUC. So on their Easter Howgate research farm, they've got this amazing project which is designed to revolutionise livestock farming. So it combines cutting-edge technology with circular economy principles. So taking cattle waste and turning it into valuable resources like renewable energy, low-carbon fertiliser, and even growing crops indoors. So it's a really fully integrated system, and it captures methane, generates electricity, and supports sustainable food production, most of all under one roof. The project is run by SRUC. The system is designed to use anaerobic digestion plant, and it will produce energy, run a methane capture system from the waste cattle bedding, and it will also produce a low-carbon fertiliser. The project itself received nearly £3 million worth of funding from the UK government's Net Zero Innovation Profile, and it's part of a broader £54 million investment aimed at supporting technologies that can remove carbon emissions from the atmosphere. And the consortium has so many great partners. So SRUC, University of Strathclyde, the UK Agri-Tech Centre, No Pollution Industrial Systems, Galebreaker, Organic Power Ireland, and Saturn Bioponics. In this podcast, we'll take you behind the scenes of GreenShed Project and interview Colin Hamilton from No Pollution Industrial Systems, Robert Brennan, the Managing Director of Organic Power Ireland, and Andrew Gardner from Galebreaker. So first up, we have Colin. Welcome to the podcast, Colin. Glad to have you here to talk about your role in the GreenShed Project. So at No Pollution, you're experts in climate-controlled research chambers. Could you describe to me a little bit about how they work and what measurements they take?
Absolutely. We have what is effectively a sealed chamber where we can recirculate the air within it while extracting a certain volume. So you've got to keep the concentration of carbon dioxide down within the chamber to make sure that the animal stays healthy. So we exhaust a certain percentage of the air, allowing a replacement to come in at the same time. We recirculate the majority of the air, which means that we can condition that air to whatever climate set point you want. So we can control the humidity and the temperature to make sure that the animal is comfortable. And with the exhausted air, we can then measure the concentrations of various gases, hydrogen, oxygen, carbon dioxide, but most importantly, methane. That's what most of the researchers are interested in. We build the system. We don't run them ourselves. We obviously offer ongoing support to all of our customers who've got the chambers that we've built installed, but it's up to the researchers themselves what sort of research they want to do, what animals they're testing. Largely it's cattle, so it's generally large ruminants. Some people are doing sheep, goat, pig research as well. We provide the system and then offer the ongoing support to our customers who are doing the research themselves.
So there must be so many complexities and challenges when you're working with gases, like capturing air, capturing methane, and the old saying goes, never work with children or animals. So how complex is the system and how do you make it work?
There's definitely complexities involved. Your flow rates are very important in terms of the amount that you're exhausting and the amount of fresh air that's coming in, your recirculation rates. We sell gas analyzers that are in the parts per million generally for methane, carbon dioxide. If you want to go further in, I believe you can measure ammonia in parts per billion. It's the technology overall is at a very basic level. What we're doing is we have a fan that recirculates the air, a fan that exhausts the air. At the point at which we are exhausting, we can sample that air, pass it through a gas analyzer and produce very accurate results, which can then be averaged out over the length of an experiment, let's say 72 hours or longer, depending on where you are in the world and what the local regulations say about keeping animals inside their chambers.
And just to rewind a little bit, the GreenShed Project started with a sister project called Green Cow at SRUC about 15 years ago.
Yeah, so our relationship with SRUC and the other partners in the GreenShed Project stems from building the climate-controlled research chambers for SRUC back in 2010. They managed to raise the funds. I think there was quite a lot of European funding involved at the time to build these chambers. There are other ones in the world that people have built previously, but this was certainly the first that were built in Scotland at this kind of scale. They are still running, although they are going to get an upgrade this year, which will renew the existing system and bring it up to the most modern standards. Out of that, the GreenShed project evolved with the various partners that are working on it together. We were an obvious choice, having spent our time handling the air within the green cow system to supply the air handling unit, the chiller, the air conditioning system for the shed.
So in terms of how your role in GreenShed developed from your role in Green Cow, is that just to do with the climate control chamber and what you're measuring?
Green Cow and the previous climate control chamber systems, they are for a single animal. This is scaled up. We're running with about 30 at the moment. The big difference is obviously you increase the number of animals, you increase the amount of moisture that's being produced. You have a larger volume of air that you need to condition as well. So the scaling up has been the interesting part of the project for us, to take what is effectively a one cow system and multiply it to be suitable for a space that holds 40 animals instead.
So when you're talking about scalability and these research chambers and what we can learn from how feed affects emissions and different nuances within that ecosystem, how does that relate to real life farming?
So I think there's a quite a difference between the research chambers, where you're particularly interested in your methane, measuring the methane at a very accurate level, whereas what we're trying to do in the GreenShed project is more to capture the methane that's being produced by a herd of animals. We are conditioning the shed to make sure that the animals are comfortable, that we stay within various set points, that the CO2 limit doesn't get too high, that the temperature and the humidity are acceptable for the animals. But what's interesting about GreenShed is that we are exhausting a certain percentage of the air, and that is being passed through the combined heat and power engine. So it's not providing the fuel for this engine, that's provided by the biogas from the anaerobic digester system. However, what we are supplying is the air for the combustion within the engine. And what's happening there is we're burning the methane that is being captured within the shed environment and turning it into carbon dioxide once it's been burned. So we're not so interested, we are interested in monitoring the methane levels. However, we're not doing it at the sort of same research level where they're not trying different feed types within the GreenShed environment. It's more about the overall concept of reducing or proving that you can reduce the methane that's being emitted from that herd of animals by passing it into a less harmful gas. At the same time, making sure we don't produce something worse, but all of our tests so far show that we're not.
That's definitely a positive. So I can't imagine how refined the technology has to be to capture methane and recycle it in this big open space, in this system where there's lots of different challenging elements.
One of the interesting things about this project is that side of things it's not super complicated. As long as you have a shed that is reasonably well sealed, and if you're exhausting at the right volumes, you run the shed at negative pressure, which means it's sucking air into the shed from the external atmosphere, meaning that the methane that's being produced by the animals inside is generally being captured within the shed. And as long as that's being exhausted through our system, we know that it's going to be processed in the way that we hope for it to be.
And how challenging is that processing element then?
The combined heat and power engine is another supplier who's dealing with that. Not to say that our responsibility ends at this point, but imagine we've ducted the air from our air handling unit. It's been exhausted by a fan there past, let's say, 40, 50 meters, who's conducting internally through the shed, out the other end to a container containing the combined heat and power engine, from where the engine extracts the volume of air that it requires, because our fan is more powerful than the combined heat and power engine intake. So we don't want to overpressure the air side of the engine. So we are providing it into a space which is then being extracted at the volume required by the engine. And any excess is then allowed to pass into the atmosphere as if it would normally from the herd of animals. So we're not processing 100% of the extracted air at the end of the day, because the size of engine that we would need for that would be absolutely enormous.
I think you're making something that's way more complicated than it sounds. Very simple.
No, that's the theory, the concept behind it is pretty simple, and it's just about being able to make that happen in the real world, making sure everything's like suitably well sealed up, making sure that our system has all of the built-in safety features that it requires, making sure that it functions within all of the licensing criteria. So the overall concept of pumping air from the shed to the engine there's nothing particularly complicated about it. It's making sure that everything works in conjunction with the other systems.
So what would you say are the real big challenges of this project?
I think with any new system like this, there's always going to be things that you learn. We've got the system running relatively well. There's things that we would refine going forward. There's things that we would simplify. There's things that we would definitely want to allow more complicated measurement to take place as well. The premise behind the whole project is that it would be retrofittable to an existing farm building. I think the scalability of it depends on making it work with existing structures, because the capital investment involved in building a new shed is pretty high. Our system has been built for this project to be able to be removed and moved to another site in future. That certainly added some complexity to how we've set it up. I think if you were installing it on a permanent basis, it would be a lot more straightforward. To make it modular like we've attempted certainly has made it more complicated, but these are all things that we can build into the design going forward.
So that integration and scalability, it feels like it's been a really important part of the GreenShed project, and that every component of this, what I see as quite a refined system, is considering scalability. Would you say that's accurate?
Yeah, I think that's accurate. The original remit was that it should all be able to be modular, so it could be moved and we could be evidenced how easy it would be to build in a new environment to be applicable to any farm who is interested in the technology. Scalable, yes. I think the larger your shed, the more animals that you're trying to have operating within the system, the bigger your chiller needs to be, the bigger your fan needs to be, the more energy consumption you're going to have. But the difference is if you're working with a herd of 100 animals inside rather than a herd of 30, it's a lot more cost effective on a per animal basis.
So in a perfect world, imagine 5 years from now, what would you like to see as an output from this project?
I think what we would like to see from this project is that, considering it's essentially a prototype, that we can get it to run sufficiently that it's producing the right volumes of electricity as predicted, that the system, the air handling unit side of the system, can maintain the desired set points within the existing shed, and then from there to see it actually applied on a existing building, a commercial deployment of the system on a non-research farm. And at the end of the day, where we are is built around the concept of trying new things, doing research within the agricultural sector. It would be very interesting, and hopefully we'll see it being deployed at a commercial level, even if it's not necessarily a 100-cow shed, even if it's at the similar size to what we're doing just now. But to see it operating in the real world would be very interesting.
For my last question, I'd love to ask, why do you think that this work is important?
I think that given the levels of consumption of meat across the world, and it seems unlikely that people are going to stop eating meat in the short to medium term unless things become phenomenally expensive. People are going to stop rearing large ruminants. And if through this project we can reduce the amount of methane that a herd of animals is producing, then that's a very small drop in the ocean compared to the number of animals that are out there. However, if it can be scaled up, if we can reduce the amount of methane that is being put into the atmosphere during the rearing process, I don't think that's a bad thing in any way. The very interesting thing as well, and it's on a sort of side note of the climate control research chamber side of the research that's going on, is that they're starting to see products being brought to market that are now considered to be methane reducing for certain breeds of animals. You're seeing selective breeding going on based on the results that have come from the research within the chambers, which are producing animals that do have lower methane emissions compared to their predecessors. I think the combination of all of the methane research that goes on around the large ruminant sector is important because it can make a significant difference across the world.
Thank you for joining me today, Colin, and teaching me all about your amazing climate control research chambers. It's been super interesting and I think really important as well. Next up, we have Robert joining us. Hi, Robert. Thank you so much for joining us today to talk about your expertise in anaerobic digestion and your involvement in the GreenShed Project.
Got involved in the GreenShed Project, delighted to be asked, because I had built a prototype small-scale AD. When I say small, we're talking containers here. And we use containers, standard containers, as the digestion vehicle because they're relatively cheap. They're also relatively mobile and easy to install. And we designed a system around that, which was luckily prototyped successfully. I then was invited to join GreenShed to build one, to be the energy provider for that project, which from a holistic point of view is trying to assess how we can better manage emissions from the production of beef. And obviously, agriculture is a big concern at the moment with regard to emissions. And this holistic project is designed to show there are ways we can mitigate those emissions and improve the health of the animal, but maintain supply of beef product.
So I just like to take a step back. You have 20 plus years in the renewable sector, and I'd really like to understand your perspective on why you think anaerobic digestion is such a good avenue to go down. And if you could briefly explain what that looks like.
Okay, good question. Inherently, we live in a take, make, and chuck society. I mean by that, we're taking resources, we make something from them, and we're finished with them, we chuck them away. And that includes a huge percentage and quantity of organic material. Everything we eat, a lot of the clothing we wear, cotton, linen, etc., all comes from the soil. On nature's holistic approach means that everything that comes from the soil eventually returns to the soil. And we as humans eat food coming from the soil or eat animals who eat plants coming from the soil to give us our energy, our minerals. But of course, there's byproducts from that all the way through the food chain, from on the farm itself, right through to the household where food waste gets chucked in the bin. And then we have ultimately also sewage sludge. And while these are different categories of wastes, as far as technology is concerned, science is concerned, we only want to know from a science point of view, what's the carbohydrate content, protein content, lignin content. In other words, how much energy is in that particular source of waste. And anaerobic digestion for waste just happens to be the simplest and therefore the cheapest energy converter that we can apply to managing the literally millions of tons of organic waste arising across the UK in any one year. And it's distinct, for example, from solar and wind, because they're reliant on nature directly. we're a little more reliant on nature indirectly. But the good news is we can then tap into that embedded energy and nutrients 24/7. And that's the big differentiator from solar and wind, which is, of course, weather dependent and sunshine dependent.
You are obviously have a lot of expertise in looking at new development opportunities, and the GreenShed project is one of those really great opportunities. So I'd love to hear about the role of the anaerobic digestion unit in that project.
On this particular site, which is a beef farm, we have some beef cattle in the shed. Beef cattle are bedded on straw, and that, of course, absorbs all the byproduct from their food, which is the cattle manures. And normally that would be taken out various times and replaced. And then eventually in spring, summertime, it would be respread back to land to put those nutrients back actually where they came from. And the straw would break down and go back into the soil. But in doing so, there's quite a lot of ammonia emissions released in that process, and they vent direct to atmosphere. And ammonia is actually a nitrogen fertilizer. So we need that to help grow the grasses and the crops. And in this instance, what we're doing at GreenShed is we're taking that straw bedding and using that as our energy source or feedstock, put into the anaerobic digester. And in so doing, we'll then generate power by breaking down the organics in a controlled environment. It's set at a particular temperature. The bacteria doing the work, because it's a natural process, operate most efficiently. And when they break down the organic material, it gives off gas called biogas, which is 50% methane. Can be higher, a little bit lower, but it's around 50%. And methane is a direct cousin, same family, as natural gas coming in from the North Sea, which also came from the breakdown of organic materials, only over a much longer period and on a much bigger scale. So that's where we get our natural gas. It's the same gas. So we shouldn't be scared of it. And then we take that gas and we, in this instance, put it into a small engine to run the engine instead of using diesel or petrol. And we have a small genset that will generate power and heat. And we'll use that power and heat to run the farm. The heat is used to maintain the body temperature in the digesters. There will be some excess heat that we may well, in the future, look to support the vertical farm on site. And indeed, there will also be carbon dioxide coming off the exhaust of the engine. We don't have the budget, but might be able to look at it in the future, capturing that CO2 also to feed into the vertical farm. And in so doing, you're beginning to see how we're getting this holistic link up. And what's left after we pull off the energy is called digestate. And of course, it's still got the nutrients, the nitrates, the phosphates, the potash, because they don't break down. They're essentially catalysts. And we will aim to feed some of that into the vertical farm to replace bought-in nutrients to grow the added value crops in there. And anything that's left, the dirty water, we have another piece of kit on site, again containerized, that can clean up the water clean enough to go down the drain. So in essence, there's no waste. So we've turned this idea of the waste byproduct of the beef production, the bulky stuff being, in this case, cattle bedding, into an energy source and a fertilizer source, just repeating the growth cycle.
I'm really interested in this because I know you mentioned earlier that you have been a part of a very big anaerobic digester. So
Yeah.
I'd like to know some of the maybe technical challenges at creating something on a smaller scale, because smaller is often harder. So I'd love to know how you're able to do that effectively.
A very good question. And you're absolutely right. It proved challenging. And the main challenge comes from the fact it's getting parts small enough for this scale, because really the market has been orientated due to financial constraints or financial drivers for bigger systems. But it means that many farms of a decent scale are missing out because the systems are just too big and expensive to be justified, and certainly not at all without some kind of financial incentive. So a lot of education is still to be done. But technically, is not the issue. The big issue is actually supply and cost, because we need pumps and pipes for this small AD, when in fact the same pumps and pipes would support a system 3-4 times larger. So you end up with quite a high fixed cost overhead for the relatively small scale and power output of this system. We're talking footprint-wise, we've got 5 20-foot containers on site, and that's it. That's our energy system. If we were to use a traditional design of large round tanks, the footprint would be some 6 times greater than that. It require foundations and concrete walls, etc. Whereas these containers were installed in less than a day. Took a while to link them all together, but they came in on a truck. They were prepared and offloaded, and we joined them up, and we're ready to run the system. So while there are lots of benefits, there are lots of pragmatic issues, challenges that are expensive, shall we say, to overcome, more than I would like. But it's because it's still a niche market, and until we get some volume, those costs are going to remain relatively high.
Yeah, so follow-on question, like someone who's been in this sector for a really long time, sees the benefit of it, been part of the development. If you could fast forward in the future, what do you think it would take for there to be small AD digesters, not only like on farms and in agriculture, but in everyday homes? Because we, like you said, we all produce waste. What would you say were the big hurdles in getting to that point?
Yeah, I think reputation can be handled with education, but it will take time. And to be honest, at the moment, we don't have that time for just waiting for behavioral change. We got to push it. And that means drivers. And there are 2 choices. There's the stick and the carrot, always. I prefer the carrot, but those have got to come from more clarity on energy policy, where at the moment, when people talk about renewables, you only ever hear of wind and solar. But in fact, the organic side of this could complement those 2 very well and be probably even bigger, but would be more beneficial in cleaning up our wastes. And we could get to the point of avoiding landfill at all for organic materials. And we should be doing it. Huge energy resource, particularly for a country that imports so much of its energy and it imports so much of its food. We're just not tapping into that resource beneficially yet. And that's a job for policy, for government policy through agriculture and also through energy. We need to get departments talking to each other, because I'm pretty sure at the minute they're all working in silos and they're not recognizing the huge benefits to be had by linking up our food production with our energy production and also our wastewater management.
So this project is super innovative, really forward thinking. It's all these different amazing elements that we're hearing about it. So what do you think that the big challenges that we face in food and farming in the UK that this type of innovation and technology addresses?
I think we need to start getting a better balance of the holistic approach to grow the food we do grow. We're using a huge quantity of synthetic fertilizer, and yet we have a huge resource of natural nitrates and phosphates in our byproducts that we're not tapping into. Part of food production needs to be properly accounted for in the current life cycle, so we can identify where the peak bits that we can approach to get bigger wins on emissions. And we hope to, through GreenShed, demonstrate how we can better manage emissions as a kind of a starting point, because it should be quite visible.
How labor intensive is it at the moment? We know farmers are so strapped for time.
Yeah, very good question. Actually, it's very limited. You're talking about a couple of hours a day. And we're just getting better and better at making these things much more automated. There's no heavy lifting. It's all mechanical, very sophisticated control and monitoring. So we can watch how it's running on our mobile phone. We can do it on a computer at site, but you can do it off site also. So that's improving all the time. And it makes the management of the waste manures. Also, we need to trade off the time input to that, to the time we would have been spending managing on those manures anyway. It's not an overburden on the farmer in terms of labor content. And you've probably heard about people who perform good husbandry, the management of livestock. Well, we would be very comfortable that anybody who performs good husbandry with livestock will also be a good operator of an AD plant, because it is a biological system after all. You just don't turn it on and off. You've got to be a little more fussy.
So yeah, it's not complicated to operate then.
Once you get the basics, it's pretty straightforward.
Brilliant. Thank you so much for joining me today, Robert. I really appreciate it. It's been really interesting to learn about the work you do. Our final guest is Andrew Gardner from Galebreaker, one of the project partners. Andrew, could you please introduce yourself?
So I'm Andrew Gardner, the Technical Director at Galebreaker Limited. And so, yeah, underneath technical at Galebreaker, we've got product development as well as animal welfare team, and also our design technicians and installation team that carry out our projects.
Great. What do Galebreaker do then? What's your speciality?
Yeah, so Galebreaker, we're actually celebrating our 40 years this year. For 40 years, Galebreaker has always been about optimizing the environment for the animal inside housed livestock buildings. Initially, it was about weather protection, but actually probably for the past 20 years, we're all about optimizing and automatically controlling the environment to create the optimum conditions for the livestock being housed. That could be dairy, young stock, beef, and also the pig sector as well.
Great. And so I'm assuming that your technology kind of addresses welfare issues as well as environmental issues.
Certainly, if we're optimizing the building environment, that could be temperature as well as fresh air. Tagline for many years was the best of outdoors, indoors. A lot of livestock have been housed outdoors in the past, but as intensive farming becomes more prevalent or prominent, they are being housed indoors. We still need to create those optimum environments for once you're inside a building, you can optimize it and be a lot more controlled to create the right conditions for the animal. So yeah, Galebreaker have got products which initially focus on natural ventilation. The best or the cheapest way to provide good ventilation is through using wind and natural airflows or buoyancy effects with a stack effect inside dairy sheds. So we've got side curtains that automatically open and close to allow fresh air into the building, and then close when the external conditions such as wind, rain need to be shut out of the building. So yeah, we very much focus on natural ventilation first, but then there's other scenarios, certainly like in young stock buildings, where to keep the temperature high, the buildings are usually quite closed, but you need to bring in fresh air, and we use positive pressure tubes that can deliver fresh air inside the building in a controlled manner.
Amazing. And what kind of service do you offer? Do you build the entire shed, or do you optimize existing buildings?
At Galebreaker are designers and manufacturers of products that fit onto existing buildings or new buildings, close up openings. We've got a door range for access solutions. We can closed door for full height doors for access, but again can be using a mesh product that allows natural air through, a mesh fabric to allow fresh air in through the doors. We've got pull-down roller blinds that go above gates to close those openings. We've also got long curtains that can go down the sides of buildings, which can effectively are rolling walls that can open and close to provide those conditions. So yeah, we're designers and manufacturers of those products. Everything is made in our factory in Ledbury in Herefordshire in England, but we export throughout the world, actually, our products. We export probably 70% of our turnover.
I would have thought the Great British weather would have influenced a lot of how your products are developed, but they're globally accessible then.
Actually, I think we're known for our quality. We design things to withstand the harsh conditions experienced in the UK, being a maritime climate. But as you go in throughout Europe, even though those weather conditions might not be so severe, they still have the same requirements, and therefore the products are still applicable. We are designers and manufacturers of the products, but we have built around that an animal welfare team that can go on farm to assess issues at hand by observing the behaviour of animals or looking at the performance of the animals. You can assess if there is an area that Galebreaker can address and improve for the farmer through correct ventilation. In the dairy sector, we looked for heat stress issues where the cows need to be kept cool. And then by providing, or we go on farm and carry out smoke tests, we can actually assess how the building ventilates and then provide a consultancy service to suggest what products could aid correct ventilation.
That's really interesting. I had a follow-on question. So have you looked into how Galebreaker products could improve productivity, or has it been shown that they do?
With the animal welfare team, not only provide consultancy service on new sales or issues with farmers to provide new solutions, we use the same team that go in to assess the value our products are brought on farm with historic customers, or we carry out funded research projects or our own research projects to really validate that our products are doing what we say they can do. So yeah, Galebreaker really do look for the correct value proposition. We recognise that our products are an investment for the farmer and therefore need to show a return on that investment.
Could you tell me about Galebreaker's role in the GreenShed Project?
Okay, so yeah, Galebreaker is a partner of the UK Agri-Tech Centre. And at the time, or when the project was being set up, Dave Ross at the time had prior knowledge of Galebreaker and approached us to be a partner because of understanding what our products could do for this one application. So certainly with regards to GreenShed, what Galebreaker's been primarily involved with is about sealing the shed to retain the methane and other gases inside the building, which is completely opposite to what Galebreaker's usually been about. Galebreaker's always designed their products to allow fresh air into the building, but then close and seal the building for harsh weather conditions outside. Galebreaker were involved in this project in the reverse manner, in the fact that they want to use our products to seal the building and then only open when it needs to, because the air handling unit isn't controlling the gases inside.
Like the reverse application of your technology, what kind of challenges have you experienced with the project?
I would say, even though we were being asked to seal the building and we were able to adapt some of our current products, the complete seal has been the challenge for us. What Galebreaker has supplied is our moving curtains on the sides of the building. Those will close when the building needs to be sealed, but open to allow it to naturally ventilate when required. The curtain is hanging on the side of the building and has a gap all the way around that perimeter. And so we've had to develop a way that as it closes, allowing it to open and close, we still had to seal all those edges to allow no air to escape. The same, we've used our ventilation light ridge in the apex of the building, where that normally has an opening and it's the airflow that passes across, or wind passes across the apex, that causes air to be sucked out of the building. We've had to create a closing flap of that ridge so that we could control how much it ventilates, or the fact that it actually needs to completely seal when we want the building to be sealed. So we've got a rotating flap in that ridge to close when it needs to. And then the same with the doors. Our doors at the ends of the building, of the central passageway, and also access into the animal areas, we've had to create seals all the way around those doors so they can still open and close like they're meant to. But obviously when closed, we couldn't have any gases escaping. So yeah, it's been the whole, still using our products to open and close the openings when required, but creating a seal when it really needs to be closed. But there's one other product, it wasn't initially planned, but from the cleaned air, or after the air goes through the air handling unit and that refreshed air comes back into the building, Galebreaker were able to suggest that actually we could use our positive pressure tubes to deliver that air throughout the building. So we've got a positive pressure tube on the air inlet back into the building that we designed so it would distribute that air throughout the pens in an efficient and uniform manner, but not causing a draft to the animal. So yeah, we've been able to provide that using our expertise in positive pressure tubes.
Just out of interest, how do you monitor? Do you use smoke then to monitor what's escaping? And surely there's still going to be gaps no matter what you do.
Yeah, there is always gaps in the building. As much as we wanted to get it completely closed, we know that's not possible. It's a big building and there's always gaps around the edges. Through the air handling unit, we've created a slight negative pressure inside the building. That means that we're sucking more air out than we're putting back in. And with that negative pressure inside the building, any gaps should be drawing air in as opposed to forcing it out. So even though there might be small gaps, we're still only drawing in air from outside as opposed to letting air escape. We've had issues, however. There was a small gap in the ridge due to how it got installed. Therefore, what we had seen when we're monitoring the air inside the building, we could see in windy conditions with our light ridge, with the air going over the ridge, it causes a natural suction effect. But when we had the flaps closed and the winds were strong outside, we were seeing that there was still air being drawn out. So even though we had a negative pressure inside the building, we were still losing some gases out through the ridge, and we've had to put additional sealing in place to improve that and address that.
That's much more complex than you imagine it would be.
Even though we sealed the building, we've had to ensure that if there is any reason that the air handling unit switches off, and that could be a power cut, or that the air quality reaches a harmful level or approaches a level which needs to be addressed, we've supplied an uninterrupted power supply that can open when it needs to. If there's a power cut and the air handling unit stops and we've got the inability to clean the air or extract the methane from the air, our curtains can still open, our ridge flaps open, and the door still has the ability to open and close to feed the animals on the feed passage. We've got a battery backup supply that can automatically do that when required. That's another bit of development that Galebreaker don't usually supply, but understanding the need for this application and to ensure the safety and the health and welfare of the animal is at the top priority, is that we've got the ability to emergency open the curtains and ridge to allow the building to naturally ventilate when required.
I love welfare being the priority. That's really nice. Last question, Andrew. I'd love to know what kind of key challenges in food and farming you think a project like this is addressing.
When you look at agriculture, it's a known fact that we've got a growing population, both nationally, internationally, and globally, that in the next 20, 30 years, the world population is going to grow by, I wish I knew the fact, I should put a fact to it. But anyway, in the next 20 to 30 years, we know that farming needs, for global food security, agriculture has to produce more food to feed the world. However, when you look at a farmer, they have the pressure of producing more, but we've also got a key priority to ensure animal welfare and that we have to do it sustainably. Agriculture gets a lot of bad press for greenhouse gases. Not to say it's the biggest producer of greenhouse gases, but it is a prominent contributor. So in the next 30 years, farmers have to produce more. They have to do it more sustainably, efficiently. And on the flip side of all that, there is a lack of labour in the market. So when you really understand all those pressing points, automation, net zero or focus on low carbon production, but also efficient production, agriculture needs to be focused. That's definitely Galebreaker's strategy for the next 20 years. And our investment in our own R&D is that we've got to ensure that we can enable farmers to produce more sustainably, efficiently and profitably as well. So people in farming, a farmer is only going to stay in farming if they can get a livelihood out of it as well. So yeah, what's GreenShed all about though is trying to tick off all those things. It is actually creating a system which can be more profitable for the farmer, but also produce more food more sustainably for the consumer.
So thank you for joining me today, Andrew. Really appreciate your time in talking about Galebreaker's role in the GreenShed project.
Thank you, Sophia.
So thank you for listening to this episode of Let's Talk Agri-Tech. It's been really exciting to learn all about the GreenShed project, and I'm looking forward to what comes next for the consortium. Head over to the UK Agri-Tech Centre website for more information, or sruc.ac.uk have a dedicated page to the GreenShed project where you can learn more. Thanks for listening and see you on the next one.